we're going to discuss one other variation of the alpha halogenation. The difference now is instead of using a base to form the enolate, we're going to use acidic conditions. And what that means is instead of an enolate, we're going to have an enol intermediate. Let's use a starting material, and it doesn't have to be, but I'm actually going to use a methyl ketone here. Now we know if this is done under basic conditions, you end up with a haloform reaction. But one important aspect to the acidic conditions, which I'll go ahead and write above here, is that you stop at monohalogenation. So let's keep this generic for now as well. And I'm just going to write X2. Like before though, X2 can be Cl2, Br2, or I2. And then we need an acid. The most common acid used with this is going to be acetic acid. Remember, acetic acid is this structure. And for this, all we're going to do is add a single halogen at the alpha position. So we lose one hydrogen, so that'll go from a CH3 to a CH2. And then you add your halogen. The byproduct of this is your hydrogen plus your other halogen. So let's walk through the mechanism for the reaction. We have our acid around. The first step, acid and a carbonyl, we always protonate the carbonyl oxygen. From here, now we can use just B as a base. You could use the conjugate base, the acetate from acetic acid if you want, or just keep it generic with B. That's going to deprotonate at the alpha position. Now, this is much more acidic than a typical alpha proton because the carbonyl is activated. So that will take the proton, we'll push the electrons like that to give us an enol. There's our enol intermediate. From here, now we're ready to react with the halogen. And let's just say we do this with bromine. Now there's a couple of ways you can draw this step and still be correct. So some people will just start with the pi bond, attack the bromine, add the bromine to the alpha position, and put a carbocation here. And you can work with that to get to the correct product. I find it a little easier to go ahead and use the lone pair on the oxygen to assist us. So we'll push that down to form the pi bond, and then that pushes the pi bond over to grab the bromine. So then what we end up with is the brominated alpha position, and we get a protonated ketone. And then just use a base to take that proton off. And there's our product. So in this case, we get the alpha halogenation product. If you want to end up with the actual HX product, what you could use as the base in this step could be the bromide that you lost up here. But I like to keep it generic and just use a B with a lone pair to say anything with a lone pair in the solution can come in and do that step.